I see that some of you haven't been there. We are 23 in Zoom, but only 13 on YouTube. Okay, thank you, Lube, for sending the link to everyone. Okay, now I will close my microphone on Zoom so that you don't have the echo. Okay, hopefully you can hear me now. If you hear me, you can open, one of you can open the microphone on Zoom and say that everything is okay, because unfortunately I see the page in the mirror image, so I need to adapt myself.
We hear you.
Okay, good. Good. So, okay, yeah. So the only problem is that this is the mirror image that I see. Hopefully you can see everything correctly. I have already tested that, even though I see the mirror image of my writing, but you still should be able to see it in the right direction. Okay, so if you remember, we started talking about the sets. So let me just refresh your memory a little bit by giving you an example. So consider the following set. A is the set of all x's belonging to the set of natural numbers such that 2x squared plus 3x minus 5 is equal to 0. Okay, which ones or which one of these statements 2 belong to A, minus 5 over 2 belongs to A, and 1 belongs to A is or are true? Okay. So let me see if I can increase the brightness a little bit. Yeah. Okay, so if you want to solve this problem, it means that if you want, if a number is supposed to be an element of A, there are two conditions that this number should meet actually. One of them is that that number should be a natural number. The other one is that that number should satisfy this equation. Okay, so it is clear that this statement 2 belongs to A. It it actually meets the first condition because 2 is a natural number. But in order to be inside this set, these 2 should also satisfy this extra condition. Okay, so but it doesn't, yes, because if you put 2 here, 2 to the 2 is 4 times 2 is 8, and this is also 6, so it is 14 minus 5 is not equal to 0. Okay, so I can say that 2 belongs to A, but 2 times 2 to the 2 plus 3 times 2 minus 5 is not equal to 0. So this tells me that 2 belongs to A is a false statement. Okay. For the second one, I don't even need to check the second harder condition, because minus 5 over 2 does not belong to the set of natural numbers. Even if it satisfies the second condition, which indeed it does, but it does not belong to the set, because to belong to the set A, we have 2 conditions to be met. Okay, so minus 2 over 2 does not belong to the set of natural numbers. So here, immediately I can conclude that minus 5 over 2 belong to A is a false statement. But for the last one, we know that 1 belongs to A, and 2 times 1 to the 2 plus 3 times 1 minus 5 is indeed equal to 0. If you do this calculation, we get indeed 0. So this means that because both of these conditions are met, we can immediately conclude that 1 belongs to the set A. So this is true. Okay, let me do another example. Yeah, I need to adjust myself a lot. So list the elements in each set. Okay, so for example, number 1, the set A is equal to x belonging to n such that 1 is less than x is less than or equal to 7.5. And number 2, I have this set B equals to the set consisting of all x's such that x is equal to n to the n plus n plus 1, where n belongs to n, and 1 is less than or equal to n less than 4. Okay, so these sets are defined mathematically. We are supposed to write all the elements in a I want to write all the elements. Okay, so if you want to do number 1, so A is the set of all natural numbers such that x lies between 1 and 7.5. Okay, so it means that if I want to name a member or an element of this set, there are 2 conditions. One is that that number should be a natural number on the one hand. On the other hand, it should lie in this interval, strictly greater than 1, less than or equal to 7.5. Okay, so it is not hard to guess that these numbers, the starting number is 2, the next number is 3, 4, 5, 6, and 7. Yes, so the important thing for this exercise is to understand how to read these symbols. Okay, so for number 2, B is the set of all x's, where this x that you want to put in this set is equal to n to the n plus n plus 1 when n belongs to the set of natural numbers and n is somewhere greater than or equal to 1 and is strictly smaller than 4. Okay, now we want to list those numbers. So be careful. Here we have two parameters involved. One is n, which is a natural number lying in this interval. The other one is x. But you see that if you read these symbols correctly, B is the set consisting of all x's with these properties, not all n's. So that is important to understand, okay? So if I want to solve number 2, the first thing that I need to say to myself is that you are telling me that n belongs to n, and you are also telling me that 1 is less than or equal to n less than 4. So I realize that there are not that many choices for my n variable. The starting n variable is 1, the next one is 2, and the final one is 3. I cannot choose 4 because n should be strictly smaller than 4. But now, if n is equal to 1, I am not interested in n actually, I am interested in x. So the formula for x is n to the n plus 1. So this becomes 1 to the 1 plus 1 plus 1. Yes, because in this case, n is equal to 1. So if I add these numbers, it becomes 3. Okay? And then n is equal to 2. What happens for x? So x becomes equal to 2 to the 2 plus n, which is again 2, and then plus 1 at the end. So if you 4 plus 2 plus 1 is 7, yes? And finally, if n is equal to 3, what happens is that x is equal to 3 to the 3 plus 3 plus 1. Yes? Okay, so I have 27 plus 3 is 30 plus 1 is 31. So this is important now that you write these numbers in your set B. So my set B consists of 3 numbers. The first one, of course, it is not good to say, it's not completely correct today to say the first one, because if you remember, I told you that there is no order considered for the elements in a set. So one of the elements is 3, the other one is 7, and the last one is actually 31. So this is the set B. Okay, now let me make sure that everything is actually working fine. So is there any question here so far? So I couldn't hear you. I need to increase the volume. Okay, do you see everything correctly on the page and everything is fine?
Yes.
Okay, good. Okay, now let us go to another example. These are the lessons from the last session. So example. Let us see which one is better to use here now. Okay, let me write this one. Let A be equal to this set. A, this curly brackets A inside, curly brackets closed, and then let me just write them instead of reading them. So let A be this set. Which one is false? Okay, so one statement tells you this, another statement tells you this, and then this one, and then this one. Okay, now let me ask you this question. So which one do you think is false here?
The middle one.
There is no middle one here. Yes. Which one do you mean? The first one, the second one, the third one, or the last one?
I'm sorry. I mean the second.
Okay, the second one is false. Yes, that's completely right. So this is the false statement. So this one is true because if you see, this whole thing is inside my set. So this is true. And as Kholu told, this is false. You shouldn't get confused because of these curly brackets be inside, because this object as a whole is an element here. So this means the last one is again true. And then A belongs to A. Because of this A, this is also true. Okay, so the false one is the second one. Yeah, thank you. Okay, so let us go to the next example here. Yeah, I probably can fit it here. So example. So let B be the set to okay, which ones? Okay, true or false? Let me make it simpler. True or false? So I will start writing them. You can start doing it yourself. So 2 belongs to B. Yeah, we can stop here. Okay, so I have a set here. This is my set. We want to evaluate each one of these statements, true or false. Okay, so what do you think about? So let us do it. So 2 belongs to B is true, because not because of this 2, because of this 2 outside. So this is important to realize why you say that this is true, even if you say this is true. So this is true because of this 2 that you see here. 2 is an element in B. This tells you that the curly brackets, 2 curly brackets closed, is not in B. So do you think this is true or false?
It is true.
It's false.
It is false, yes? Because this claims that, yeah, curly brackets 2 does not belong to 2, but this is a false statement because it belongs to B. So this is a false statement. Okay, the next one is false. Okay, even though you see some 6s there, but it is very important to realize this 6 without any curly brackets is not seen as the elements of B. If I ask you how many elements are there in B, you would say 1, which is just simply 2. The other one, number 2, is this one. The third one is this one. And the fourth one is the whole expression here. So this set contains 4 elements. So this is false, and this is also false. Yes. And this tells you that. So what about this one? Do you think this is true or false?
True.
This is true. Yes, because if you see, this element is not one of the elements of the set B. And this is also telling you that this is not in B. So this is also true. And then this one is true or false?
It is false.
It is false. And the next ones I think are easy. 4 belongs to B. Hopefully everyone realizes that this is also a false statement. 5 does not belong to B. It's a true statement. Yes? Okay, so let us go to the next page. Yeah, so I need to adjust this. Okay, so let me do another example. In which one of the following sets from, I don't know how to express myself properly, hopefully this is clear, from every pair of distinct elements chosen, one element is an element of the other. Okay, so these are my sets. I have one set I have another set. I have 2 more. Okay, I just want to wait for you a little bit so that you can understand the question and try to answer me. Whenever you have the answer, please let me know. Yes?
I think it's the set containing 1 and the set containing 1 and 2.
You mean the last one?
If I'm not mistaken.
You mean this one? I am this one?
Well, maybe I misunderstood the question.
No, I mean
Yeah, that's one that's contained entirely inside of.
No, contained is different from being element.
The one above. Okay.
Anyone else?
Babak, I don't understand the question.
Yeah, I will of course explain the question, but so let me explain the question, okay? So, for example, if you consider this set, how many elements are there? I have 3 elements. One of them is B, one of them is curly brackets B, and then I have curly bracket B, okay? So I have 3 elements here. I can have 3 choices of a pair of elements, yes? So for example, here, let me consider this set, the first set. I have B, and I have this, and I have this. Okay, this has been mentioned from every pair of distinct elements chosen. So how many pair of elements I can choose from this set? I can choose this pair. This is one pair that I can choose from this set. I can choose this pair. And then I can also choose this pair. Yes, so I have mentioned from every pair of distinct elements chosen. Okay, so consider the first set, for example. There are 3 elements there. I want to choose a pair of elements from my set. I can do it in 3 different ways. One of them is to choose B, the first one and the second. One way is to choose the second one and the third one. But of course, one way is also to choose the first one and the third one here. Now I am asking, is it true that in each pair, one is the element of the other? Let us check them. For this pair, that is true because B is an element of the second one. Yes, so at least one of them is an element of the other, even though the right-hand side one is not an element of the left-hand side one, but the left-hand side one is a pair of the right-hand side one, is an element of the right-hand side. So that, so far so good. But then I go to this pair. Is it true that one of them is an element of the other one? Again, the answer is yes, because the left-hand side one is an element of the right-hand side one. So far everything works. But when I reach to the last pair, is it true that this one belongs to this one? The answer is no, because B is not an element of this. The other way around is not true as well, because this one also does not belong to this one. So this cannot be chosen. So this is not what I want. Okay, this is not the answer. Okay, hopefully I could explain it properly. So do you understand now? So it means that when you go to a set, you need to see how many pairs of elements you can choose, and then check if it is true or not that one of them is an element of the other one. Okay, so for example, let me check this one as well. So let me just do this one as well. So you see that we have 3 elements, 1, curly brackets 1, curly brackets 1 and 2. So I have 3 elements. So again, how many pair of elements I can choose? So let me write it here, 1 and 1 and 1 and 2. How many pair of elements I can choose? I can choose 1 and 1. I can choose 1 and 1 and 2. Finally, I can choose curly brackets 1 and curly brackets 1 and 2. Again, this one, the left-hand side one, is a member of the right-hand side one. The left-hand side one is the member of the right-hand side one. But here, neither the left-hand side is a member of the right-hand side, nor the right-hand side is a member of the left-hand side. So this is not the answer again. Okay? Okay, now my question is that which one is the answer? Let me just show it again. So which one is the answer now? So I checked the first one and the second one. They were not the answer.
The first one.
I checked.
No, I mean, the second one. Couldn't you say that one is
this one
of the set of one? No, I mean the top right one.
The top right one, I just checked it here. It was not the answer.
Yeah.
No. The third one.
It should be, because one is an element of the set of.
No, I just wrote it here, Alex. So if you are saying this is the answer, this is not the answer. I checked it here. So I have 3 pairs, 1 and curly brackets 1, 1 and curly brackets 1 and 2, curly brackets 1, curly brackets 1 and 2. The first one, the left one, is a member. That's okay. Here also the left-hand side one is a member of the right-hand side one. But for the third pair, neither the first one nor the second one are the element of one another. So this is not the answer. If I choose this pair, this is not working. But as Khulud say, I think she said that this one is the correct answer. And I think this is the correct answer. Yes. Let us check that one. If I have this A and curly A, and then I have curly A, so again, how many pair of elements I can choose? I can choose A and curly A. I can choose A and curly A, and I can choose curly A, curly A, something like that. But if I ask you now from this pair, is it true that one of them is an element of the other? The answer is yes, because the left-hand side is A, the right-hand side is curly A, and the left-hand side belongs to the right-hand side. So that is okay. Next test. I have 2 sets involved. There's 2 elements involved here. One of them is A, the other one is the whole expression that you can see here. Is it true that the left-hand side is a member of the right-hand side? The answer is yes. So, okay, that is also okay. But if I go to the third one, this is also okay, because again, the whole expression that you see here is still an element of the right-hand side. So it means that if I take this set into account, it doesn't matter which pair of elements I choose from this set. I can choose only 3 pairs, and in each one of them, at least one of them is a member of the other. So this is the answer. Okay, but let us check the last one. The last one is not the answer, because how many pairs can I have there? This set contains 2 elements. One of them is curly 1, the other one is curly 1 and 2. Okay, so I can choose only 1 pair. Is it true that this belongs to this? No, it is false. Is it true that the other way around is correct? Again, this is a false statement. So this is not the answer again. Okay, I hope that everyone understands what is going on. Yes, these are very simple things, but you need to be very careful to understand that and answer the questions correctly. So I just want to wait a little bit for you so that you can see everything. So is there any questions? We had these 4 sets. The question was that in which one of them, from every pair that I choose, one is an element of the other one. I hope that I could convince you that all of them, only the third one is the correct answer.
I thought the question is, in which ones is there at least one pair?
I don't know. Hopefully what I have written in English words is correct, because I have written, if you see, I have written in which one of the following sets from every pair of distinct elements chosen, one element is an element of the other one. The containing thing we haven't studied yet. That is called subset. I will hopefully talk about that today, but we haven't started that concept yet. Okay, so let me, there is one thing, I don't know, in Swedish system, they haven't even talked about that, but let me just talk about it here. So definition. And that is the notion of interval. Of course, you know what an interval is, but I want to talk it more formally here. So you can say that I have a set of x. All the x's should be real numbers such that x lies between these two numbers. Okay, so I would say that let a and b be real numbers and a is less than or equal to b. Okay, so this set is an interval. Yes, it tells you that I am interested in all real numbers which lie between a and b. Okay, so this is one particular type of an interval. There is a notation for this. You know the notion of interval in Swedish system, but you will never study the symbols for them. So the symbol which is used in mathematics for this is brackets a comma b brackets closed. Okay, so if I want to draw a picture for this, so you would say that if this is the real line, for example, say this is the x-axis, then I have a point here on the axis A, I have another point on the axis B, and every element between A and B is acceptable for me. So this is a graph. It is a picture representing that I am trying. So, and then it is crucial to leave these two small circles open. It means that you are emphasizing that A and B are excluded from this set. This is what we call an interval. We have different types of interval. I want just to introduce them here. So that's not a conceptual lesson. I'm just introducing the names and the symbols or the notations that we use for that. Another possibility is that we can have the set of all elements in R. We can include A, but we still can exclude B. This is also an interval. If I want to denote it, usually in mathematics, it is denoted by square brackets for A, emphasizing that A is included, but just normal parentheses for B, which means that this is not included, B is not included. So if I want to draw a picture for that, so this means that I have somewhere A, but I put A filled. It means that I am including A, but still I am excluding B. So I put the hollow circle at the end. So this is the picture that represents this interval. Of course, then it becomes clear that you can do it the other way around. This is A less than X less than or equal to B. And this is denoted by parentheses A and square brackets, B square brackets. Okay. And then this one, of course, you can guess what is coming next. You can include both of them. Okay, so this means you denote it by this symbol. Okay, this last one is called a closed interval. Okay, this first one is called an open interval. Okay, so these two, you can call it half open or half closed. But when we say a closed interval, we mean that we need to include both endpoints. And when we say an open interval, these are just words that we use in mathematics. So an open interval means an interval not containing the endpoints. All of them are called bounded intervals. Okay, the reason is that we can also another type of intervals which is called the unbounded intervals. Okay, so unbounded intervals are like this. For example, I can have A up to plus infinity. This means that I can have this situation. All the x's in R which are strictly greater than A. you can have this situation. This means that you have x belonging to R, but x is greater than or equal to A. You can have also in the other direction. You can go from minus infinity to some point, say, for example, A, and close it. This becomes x belongs to R, where x is strictly less than A, and you can have this situation. These are very, very famous. I don't know why they haven't talked about this in the Swedish books. So these are also intervals, but they are called unbounded intervals. So this is also good to know. So these notations I want you to know, because the notion of the set is very simple. So all these 4 before and 4 now, these are called intervals. The previous 4 are called bounded intervals, and these 4 are called unbounded intervals. It's very good to know about this notion as well. Okay, and then let us go to another definition, which is again in the book. A set that has so how should I say this? A set so let me write this. A set whose number of elements is a non-negative integer is called a finite set. Okay, so this notion of finite, of course you understand that, but let me make it formal. So if I have a set, if I count the number of elements inside the set, it turns out to be a non-negative integer, then I would say that that set is a finite set. Okay, the number of elements in a finite set, in a finite set A, is called, this is a big name but a very simple thing, so in a finite set A is called the cardinality of A, and it is denoted by something like absolute value. But this is not confusing, because absolute value, when you say absolute value, inside the absolute value you expect to have a real number. But if you have the same symbol, absolute values kind of symbol, but inside that symbol you have a set, this means that you are referring to the cardinality of that set, which means the number of elements inside your set. Okay, if a set is not finite, it is called an infinite set. So these are the words that are introduced in the book so that I want to know: finite, cardinality, and infinite. So for example, if I want to give you a simple example, if I have this A equals to a square root of 3 minus 5 over 2 A, and for example B squared, and this one If I ask you, is this a finite set or an infinite set? The answer is clear. This is a finite set, and the cardinality of this set, so A is finite. And the cardinality of A is the number of elements that you see. 1, 2, 3, 4, and 5. So that's the cardinality of this set. And if I want to give you examples of infinite sets, all the famous sets that we have so far, for example, the set of natural numbers, the set of, I don't know, integers, the set of rational numbers, the set of real numbers, the set of complex numbers are all infinite sets. Yes, and then we don't usually ask about the cardinality of these sets. But of course, if you remember, Contour also start talking about the cardinalities, because if this is not in your lesson, just for extra information. So we know that the number of elements in the set N is infinite. We also know that the number of elements in the set Z is also infinite. But you might have the feeling,
Baba,
yes? Yes, Khulud?
and the first one there is a negative.
Pardon?
That's a finite.
I don't understand your question. May you repeat it?
Yeah, and yes, and A there's a negative number. You said a finite doesn't have negative number.
It's a non-negative number, yes. So the number of elements of a set, if the number of the elements of a set is a non-negative number, the reason that I mentioned non-negative because it can be 0, yes. So I will talk about this. So let me just tell you, for example, the cardinality of empty set is 0. 0 is not a positive number, it's a non-negative number. Is that your question?
Okay, no, I understood that.
Okay.
I got something else.
So non-negative,
Yeah, thank you.
so let me just mention, when I say non-negative, it is different from saying positive. Let me just explain if this is a matter of confusion. When I say positive, it means a strictly greater than 0. But when I say non-negative, it is greater than or equal to 0. So this is the extreme case, because the cardinality of the empty set is 0, and the empty set is categorized under the finite set. So if I say that the empty set is a finite set or infinite set, you would say this is a finite set because there are no elements inside the empty set, so the cardinality is 0. 0 is a non-negative number, non-negative integer, so it means that this is also a finite set. That's also good to know. So let me also give you another terminology that is called singleton. Let me finish this one, then I will come back to this. So all these sets that I have written here are infinite sets. So the notion of infinity is very confusing. It was not even trivial for mathematicians. So here, if you see this set N, if I ask you what is the cardinality of N, this is not a sensible question. So because the cardinality is only defined, of course, this is not true. The cardinality in the high school is defined for this finite sets. But we can also talk about cardinality of N and cardinality of Z. Of course, both of them are infinite, but still we can compare the infinities together in the set theory. So that's a very big success in set theory. So might be you have this feeling that the number of elements in N is less than the number of elements in Z. Of course, the notion of having a smaller number of elements is a little bit misleading here, because both of them have infinitely many elements in them. So, but intuitively you feel that whatever infinity this one is, this infinity should be 2 times larger. But of course, 2 times larger of infinity is also something like infinity. So you might feel that this set Z is bigger than this set. So bigger in quotation, okay? But it turns out to be that no, they have more or less exactly the same number of elements, but not the notion of number should be in quotation mark again. So if I want to compare these two infinities, the infinities here are of the same rank. And then the same thing for even Q. But when it comes to R, then suddenly the cardinality of R, the infinity here is of higher rank. So that somehow this means that the number of elements in R is much bigger than the number of elements in N. But the surprising thing is that, okay, the number of elements here are the same, more or less. So I don't want to spend so much time on it. Might be we will talk about that a little bit later. But this, I want you to know, the notion of finite set, cardinality, and infinite sets. All of these sets are infinite sets. Empty set is a finite set. Its cardinality is 0. And there is also another notion. If the cardinality of a set is equal to 1, then A is called a singleton. This is also you need to know. So a singleton is a set with exactly one element in it. So for example, this set that I write here one more. Yes. So this set that I have written here, can you tell me what is the cardinality of this set? So let me call it set X. My question is that what is the cardinality of X?
It's 1.
Yeah, it is 1, yes? Because this set contains this expression, you see? The whole package that I am just putting in a box, this is exactly one element of the set X. So actually X is a singleton, yeah? So this question mark is now clear. This is equal to 1. So X is a singleton. Okay. Now we go to the very important notion of that is a set contains another set. Okay, so this is a very important concept. So definition. Let A and B be sets. We say A is a subset. So this is the word that you need to remember, is a subset of B, and we write A is a subset of B. This is the symbol that you write. If every element of A is an element of B. Okay, so that is a very important notion. This is the notion of subset, and this is the symbol that we use. Okay, so if I want to write it mathematically, when I say that A is a subset of B, what I mean, this statement is equivalent to saying this. For all X, if X belongs to A, then X belongs to B as well. That is the meaning of a set being a subset of the other set. For example, I write two sets here for you. So one of them is 1, 2, 1 and 2, containing 1 and 2. And the other one is, for example, 2, 3, 5, and 1. Okay? If I say, do you think that A belongs to B? This is false. You see, I just want to compare because sometimes the students get confused between this symbol of being belonged to and the symbol of this subset. This is false. But if I write for the same two sets, if I write this symbol, this is true. So I hope that you understand. I will, of course, give you more examples. So when I say that a set A belongs to the set B, it means that this package as a whole should be inside B, should be an element of B. But I will also have another symbol, which is the subset symbol. If I want to see if this symbol is true, if this statement is true or false, I don't care about the whole package of A. I care only about the elements of A. The elements of A are just 1 and 2. And I will check. If 1 is also here, the answer is yes, because you see 1 is also here. The other element is 2. Is 2 also in B? You see yes, that is also true. So it means that every element of the set A is also an element of set B. So this is true, but this was false. Okay, so for example, if I want to draw a Venn diagram to represent this, do you remember? Usually we draw this universal set. I big a rectangle for the universal set. So assume that you have this is your set. When you say A is a subset of B, it means that A is somewhere inside B, something like this. Okay, Venn diagram. That represents this statement. A is a subset of B, not being belonged to. So this is my universal set. I have a set. I have another set. As you said now, Alex, is contained in the set B. So being contained is just a notion of it being subset. Okay, and then for example, between these famous sets, you know that the set of natural numbers is a subset of the set of all integers. Why? Because every natural number that you choose from n, every natural number that you choose from n is also an integer. And the set of integers is itself a subset of rational numbers, because every integer that you choose can be written as the form of a fraction if you give the denominator a 1, yes? And this one itself is a subset of the set of real numbers, and somehow you can convince yourself that this is also a subset of the complex numbers. So I want you to differentiate between these two concepts, being belonged to or being a subset of another set. Okay? Okay, so something I want to mention, I wrote that A is a subset of B means that it's equivalent to this statement. X, if X belongs to A, then X belongs to B. Okay, can you translate the negation of this for me? When I say that A is not a subset of B, what does this mean? Just say it in English words, then if you want, I can write it in mathematical symbols. But what do you mean when I say that A is not a subset of B? When you say A is a subset of B, it means that whatever you find inside A is also inside B. But when you say that A is not a subset of B, what does this mean?
That for every x, x belongs to A, then x does not belong to B.
No, no.
Is that there exists an x in A such that it does not belong to B?
Yes, exactly. So when you say that A is a subset of B, it means that whatever I find in A is in B. When you say that A is not a subset of B, it means that I was able to find at least one element which was in A but not in B. That is the meaning. And that for the people who have math specialization, we have already studied the negation of this quantifier is the existential quantifier. And then if you want to negate P, just in passing for those people who have this, okay, so we know that this is equivalent to negation of, so the first one and the negation of the second one. But you really don't need, you see, you don't need to know these formal things. So this is important to understand. When I say A is a subset of B, it means whatever I find in A is also in B. When you say that this is not the case, it means that at least I was able to find I was able to find at least one element which was in A, but when I look for it in B, I cannot find it. So this is also good to remember, that this is also important. Another important thing is that, so for example, another important thing is that, let me write two sets here for you. I would write 1, 2. I would write B, 2, 3. Which one of these statements are true? Is this true or this one is true?
None of them are true.
None of them is true, yes, because when you say A is a subset of B, it means that whatever is inside A is also inside B. But this is not the case, because you find one element, 1, which is in A, but it is not in B. So this is false. And then, what about the second one? Is this true? Again, the answer is no, because you can find an element here which is 3, but it is not in A. So this is also false. The reason that I gave you this example, because sometimes people draw an analogy between this symbol in set theory and this symbol in real numbers. Yes, there are some analogies between these symbols, but they are not exactly the same. So you shouldn't draw this analogy, push this analogy so far, okay? So you really need to understand what is going on. Because this is the main difference between this symbol in set theory and this symbol between real numbers. This relation between sets and this relation between real numbers. You see that if A and B are real numbers, there is guarantee that either this one is true or this one is true, yes? If A and B are real numbers, at least one of them is true. And if A and B are equal, so of course both of them are the same and they are true. But there is no such a guarantee when it comes to sets. It might happen that we have two sets, none of them is a subset of the other one. So it means that if you want to know the terminology, this one is a total order. So using this relationship, I can put the real numbers in a perfect order. Everyone, so I immediately see that I can, for example, arrange the numbers in a, of course, arranging infinitely many numbers is a different topic, but at least I can have an order, a total order on the set of real numbers using this relation. But there is no guarantee that I can have a total order between sets. For example, there is no relation between these two sets that I have mentioned here. I cannot say which one in the code is bigger than the other one. None of them. A is contained in B is false. B is contained in A is also false. Okay, so this is something we have. It's called partial order. But I just don't want you to be bothered about these things anymore. So this is very important to understand. Okay, so a very important example that I want to mention here is this, to understand the difference between this belonging and subset in a better way. So let me just give you this example. Consider the following sets. So the set is, I want to give you a little bit of time after I finished. I want to wait for you to do this exercise yourself first. Yeah, make sure that you really understand what's going on. Okay, so specify the truth or falsity of each statement. Okay, so I will write the statements. You can start thinking about them. Okay, I want to wait a little bit for you to see how do you answer this. Each one is a separate statement. Okay, I want to wait for you. I think 2 or 3 minutes would be enough.
I think I'm done now.
Okay, so I just want to wait 2 more minutes for others. Okay, now let us fix this. Yeah, that's good. So I have 4 sets, A, B, C, and D, and then I have a bunch of statements. We want to check which one is true and which one is false. Okay, so 1 belongs to A. So I don't think this is hard at all. So there is a difference between this symbol belonging to and this symbol as a subset. Okay, so 1 belongs to A. It means that you go and look inside A and only care about the elements. So the elements of A, one of them is 1, the other one is 2, and the other one is the whole package of curly brackets 1 and 2, curly brackets closed. Yes, and this is claiming that 1 is one of them. So this is true, yes, because of this first one, not because of this one that you see here. The reason that this is true is because of this one here. So what about the second one? The second one even doesn't make sense at all. So it is not a well-defined statement, because when you use this symbol, you need to compare 2 sets. What is on the left should be a set. What is on the right should also be a set, because the notion of being subset is defined between 2 sets. So I would say that this is false. If I want to mention it more, I would say this is not well defined at all, because I haven't followed the grammar. Yes, the grammar is that what you see on the left should be a set, which is not in this case, of course. But now let me ask you, what do you think about the third statement? Is it true or false? You have enough experience of this symbol. I don't think it should be hard for you. What is this third one?
False.
Yeah, it is false. Okay, now let us go and see. You see, I have intentionally written both of them. B belongs to A. B is a subset of A. Okay, let us see what happens. Does B belong to A is a correct statement. Is this true or false? B belongs to A. Don't have any idea? Okay, so let me mention it. Why? So I don't know. Can you hear me? It's not that hard.
That's a false statement.
Yeah, that's a false statement. B belongs to A is a false statement. Because when you say B belongs to A, it means that the whole B should be an element of A. But this is not the case. Yes, the whole B contains 2 curly brackets from the left and 2 curly brackets from the right. But you don't see this inside A. What you see that is close to this is just this one, but this contains 1 curly brackets on each side. So this is a false statement. But now let us consider this statement. Is this a statement true or false now?
True.
This one is true, because when I use this symbol, it means that I need to check what are the elements of B and to see that are those elements also inside A or not. But if I ask you what are the elements of B, there's only one element, and that element is curly brackets 1 and 2. Okay, this package, curly brackets 1 and 2, also belongs to A. So this statement is true. You see, this statement, belonging statement, was wrong, it was false, but this statement is true. I want to make sure that you understand the difference between these two. If there's any questions, please let me know. You can interrupt me, okay? So the next one, 1 belongs to B. It's clearly false, yes? Yeah, I don't think you have a hard time to understand that. So this is false. Let me make it clear that is false. Now we go to this one. I want you to have practice here. C is a subset of B. So if I want to check if this is true or not, I need to check the elements of C. The elements of C are just 1 and 2. Now let us do it one by one. Does 1 belong to B? No. So here I don't need to continue anymore. This is false because I was able to find an element in C which is not in B. So this is false. But C belongs to B. C itself is this package, curly brackets 1 and 2. Does this belong to the set B? Yes, because B contains exactly 1 element, and that element is curly brackets 1 and 2, curly brackets closed, which is exactly C. So this is true. But let me go here. Compare C and A. This is a little bit more interesting example. Is C a subset of A, true or false? Whenever I see subset, I need to see the elements inside C. The elements inside C are 1 and 2. And then I need to see, are these elements also in A or not? 1 is in C. 1 here is also in A. So that is good. The next element is 2. Here 2 also is an element. So every element here is also an element here. So this means that this is true. C belongs to A. This is also true. You see, it's very important to realize because C as a package 1 over 2 is also an element of A. You see, A has 3 elements, 1, 2, and this whole package. Yes? So C is this one here. So this is a good example. You see that in this case, belonging relation was false, but subset relation was true. Yes? Here, the subset relation was false, belonging relation was true. Here, both of them are true. So it can happen. So you can cook up examples that either one of these situations can happen. So that is also true. But the next one, let us check that one. Is this true or false? If I want to check this, I need to see, is this true that every element here is also an element here? There is only one element here, and that is 1. Is it an element of D? No, because this is an element of D, which is not this one. So this is false. It's very important to understand what is going on. This statement is true, actually, because this is belonging relation here. So the curly bracket 1 is an element of my set. So this is true. What about this one? If you want to check subset relation, you need to see that whatever is inside the first set is also inside the second set. Whatever is inside the first set is just this curly bracket A1. Is it an element of D? Yes, the curly bracket is an element of D. So this means that this is also true. But if I say, does 1 belong to D? The answer is clearly false. So this is a very simple example, but I think it's very illuminating, and it shows you the main difference, how you need to understand the difference between this symbol of being belonged to and this symbol of being a subset. Okay? I will scan these notes and put the link in the Google Drive folder, as well as the below this video in the description on YouTube. Okay? Is there any questions here? Because I want to stop here. Is there any questions regarding this example? This is a simple but very important example. Okay, so I will end this in live stream and go back to Zoom for just one single moment.